So in this lesson, we're going to be learning about standard index form. Now, hopefully you'll remember that the word index also means power, so to the power of. So it's when we write, for example, x to the power of n, that is our index. But first off, I'd like you to pause this video and have a go at answering these questions and try to answer them without using a calculator. I'm going to put the answers up. Now, hopefully you'll start to see a bit of a pattern when you are answering your questions. You'll see a bit of a pattern that the amount of zeros in your answers correspond to the number that your 10 is to the power of. So, for example, 10 to the power of 4 is 10,000, and you've got 1, 2, 3, 4 zeros. We've got 10 to the power of minus 1. We've got 1 0. It's a negative, so it becomes smaller. And then remember that anything at all to the power of 0 is always going to be 1. But this should hopefully indicate a little bit of help as to how we're going to figure out answers for today's lesson. So, standard index form, what is its definition? You can use standard form to represent very large or very small numbers. The standard form makes use of the laws of indices, but numbers are only expressed in one base, the base of 10. This will become a bit more apparent next. So, a number in its standard form, if it is written as a times by 10 to the power of m, where a is equal to or bigger than 1 and smaller than 10. So what this means is that your a value here has to be between 1 and 10, but it can be equal to 1, but it can't be equal to 10. Hopefully these symbols will make a bit more sense and you'll know what they mean. So a can be 1 or bigger, or basically 9.99999 or smaller. It can't be 10. It has to be a 1 integer in front of your decimal number, and this will make a bit more sense as we go along. So some examples. So 2.5 times by 10 to the power of 3, 1 times 10 to the power of 7, 1.4 times 10 to the power of minus 8. These are all numbers that are written in standard form. They all comply with the rule. All of these numbers in front of your times are all between 1 and 10. Even if you've got decimals, it still is smaller than 10. And your n, so you've got 10 to the power of n, you have a power. One thing that I need you to note down in your books is this formula. So a times 10 to the power of n is where a is equal to or bigger than 1 but smaller than 10. So make sure you have this written down in your books so that you know what standard form is and how you have to write it. Now these are a couple of non-examples. So 13 times 10 to the power of 5 is not in standard form. And why is that? It's because 13 is larger than 10. It's an expression, but it's not in standard form because 13 is not in the correct standard form because it's bigger than 10. And another example here that isn't standard form is 0.75 times by 10 to the power of 4. This is not in standard form because 0.75 is less than 1. And remember, this number here, the same as this one here, has to be between 1 and 10, and they are not. Therefore, they're not in standard form. Now, we're going to learn how to convert numbers into standard form, and also how to convert these sorts of expressions also into standard form. Another couple of definitions is standard form is a way of writing numbers which can be particularly useful for working with very large or very small numbers. It is based on using powers of 10 to express how big or how small a number is. So standard form is written in the form a times 10 to the power of n, where a is a number bigger than or equal to 1 and less than 10. And n can be any positive or negative whole number. Okay, it's important to know that this number here can be any number between 1 and 10, but it can be decimals. However, this n, your power, has to be a whole number, but it can be a positive or negative whole number. And how it's used, or a little bit of how it's used. So scientists use standard form when working with the speed of light and distances between galaxies, which can be enormous. The size of bacteria or atoms may also be referred to in standard form as they are really tiny. So really, really big things and really, really small things can be used with standard form to make it a bit easier to write out and explain. So this is a bit more an extra example here. So 45,000 can't be written as 45 times by 1,000, which is 45 times by 10 to the power of 3. Why is that? Because 45 is not in standard form. It has to be written as 4.5 times by 10,000, which is 4.5 times by 10 to the power of 4. Now, one thing you'll notice here is you'll see that we've moved our decimal back once. So it becomes 4.5, and because we've moved it back once, what we've done is we've added a power. Now, hopefully this will become a bit more apparent when we go through the following examples. So when changing large numbers into standard index form, the index notation will be positive. Please make sure that you note this down and the examples that I go through on this page. So when changing large numbers into standard index form, the index notation will always be positive. What that means is that when you do times 10 to the power of n, your n is going to be a positive whole number. So let's have a look. We've got 24,900 as a number, and we have to write this in standard form. So first thing you're going to do is put your decimal where you'd have your correct notation of 1 equal to or greater than 1 but less than 10. So if we were to look at this number, where will we put our decimal? Between the 2 and the 4. And then we count how many times did our decimal place move from here back to where we've put it now. So it goes back once, twice, 3 times, 4 times. So it's gone back 4 times. Therefore, it's going to be 2.49 times by 10 to the power of 4. Remember, because it's a large number, okay, our index notation will be positive. So we have a positive 4 there. So 2.49 times by 10 to the power of 4. We've moved our decimal place back 4 times. Let's have a look at another example. So we've got a really big number here. So where will we put our decimal place in order for it to become correct? It would be between the 7 and the 8. So we get 7.8. And then our decimal would have originally been here. So how many times are we moving it backwards? We're moving it once, twice, 3, 4, 5, 6, 7, 8, 9 times. So your final answer would be 7.8 times 10 to the power of 9 in standard form. Now, if you're given something like this, but it's not in standard form, but you have to convert that into standard form. So where would your decimal go? It would go between the 5 and the 4. You're moving your decimal backwards 2 spaces. So because you're moving it back 2 spaces and it's a positive, you're having to add on 2 to your power. So you end up with 5.43 times by 10 to the power of 7. Okay, it might seem a bit confusing because you're moving backwards, but you're adding on 2. But just remember, if you have a large number and you're putting it into standard form, it's always going to be positive. Another example, we've got 1,700 times by 10 to the power of minus 8. So our decimal would go between the 1 and the 7, and we're moving our decimal place back once, twice, 3 times. So it would give us an answer of 1.7 times 10 to the power of minus 5. So remember, we're adding on 3. So minus 8 plus 3 gives us an answer of minus 5. So what I'd like to do is pause this video and have a go at these questions. So remember, what you're doing is writing these in standard form. The first 3 rows are writing them in standard form. The next row, which is this one where it starts with M, you're having to write them in standard form, but remembering to add on to your power. Okay, let's pop the answers up. So pause this video and make sure that your answers are marked. Now what we're going to do is converting to standard form where we have small numbers. So when changing small numbers into standard index form, the index notation will be negative. So what that means is when we're doing times by 10 to the power of n, our n is going to be a negative number. Remember, it's a whole number. So first one, we've got 0.049. So where would our decimal have to be in order for it to comply with our rule, which has to be a has to be between 1 and 10. So our decimal place would have to be between the 4 and the 9. And how many places are we moving our decimal? We're moving it once, twice. Okay, so because we're moving it twice, it becomes 4.9 times by 10 to the power of minus 2. So we have a small number. Because it's going to have to become bigger for it to comply with standard form rule, it becomes 4.9 times by 10 to the power of minus 2. Remember, when it's a small number and you're putting it into standard form, your index notation will be negative, so that's where the -2 comes from. Another example, got 0 point, lots of zeros, and then 8, 2, 1. So our decimal would be between the 8 and the 2, which would mean we end up with 8.21. But now we're going to see what we're going to times 10 to the power of what in order to make that in the standard form. So our decimal moves once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. So it becomes 8.21 times by 10 to the power of -9. Now, if we have an example like this where we have to write this into the correct standard form, so our decimal will go between the 2 threes, and our original decimal place will move once, twice, 3 times. Now remember, because it's a small number, it's going to be a negative, so we're going to have to take away 3. So it moves 3 times, so we're taking away 3 from that power of 7. So another example, 0.071 times by 10 to the power of -11. Our correct place would have to be between the 7 and the 1, so we get 7.1, and that corresponds with our rule of it being between 1 and 10, times by 1, 2 spaces, 10 to the power of -13. So remember, you're taking away 2 because you're moving your decimal 2 spaces, so it becomes 3.3 times by 10 to the power of -13. -11, take away 2 is -13. So pause this video and have a go at these questions. So very similar to the previous exercise, what you're doing is writing these in standard form. Now I'm going to put the answers up. Pause the video if you need to mark your answers. And now moving on. So convert into ordinary numbers. What this means, ordinary numbers, it's basically you're taking out the times 10 to the power of and just writing the number as it is. So if we have 2.9 times by 10 to the power of 3, we have to write this into ordinary number. So it's times 10 to the power of 3. That means our decimal place is moving to the right. It's becoming a bigger number. It's going to move 3 times. So 1, 2, 3. That's where our new decimal place will be. And now we have to put our placeholders of 0. So our answer to 2.9 times by 10 to the power of 3 is 2,900. What about if it's a negative? So we've got 9.1 times by 10 to the power of -5. So our 9.1 is there, and because it's a -5, it means we're moving to the left 5 times because it's becoming a small number. Remember, if it's a positive power, it's becoming a bigger number. If it's a negative power, it's becoming a smaller number. So we're going to move our decimal to the left 5 times. So 1, 2, 3, 4, 5. Put in our new decimal place and then input our zeros for placeholders. So we end up with 0.000091 as our answer. Now what I'd like to do is pause this video and have a go at these questions. So what you're doing is writing the standard form into ordinary numbers. So taking away the times 10 to the power of and writing it as a full number itself. And I'm going to put the answers up, so mark your answers as we go along. So we've got quite big numbers towards the end. Make sure that they are marked.